Okay, everybody, continuing the video and finishing up this lesson. What's the probability that I can draw a black king and a club? That is the probability of both occurring together, which we just found right here, and the probability is just 1 out of 52. All right, let's do E and F. What's the probability that I draw an even number or a black card? Well, even numbers are 2, 4, 6, 8, and 10 in a deck of cards. So each of those have 4 cards. So there's 4, 8, 12, 16, 20 even numbers. There's 20 cards that are even out of 52. Or means to add. Of these 4 2s, 2 of them are red and 2 of them are black. Of the 4s, 2 are red and 2 are black, and so on and so forth. So 2 of each are red and 2 of each are black. So I'm going to subtract, or I'm going to add 2 plus 2 plus 2 plus 2 plus 2. That's 10 cards that are red and 10 cards that are black. But that means there's 10 cards I counted twice. So I'm going to subtract away. I'm going to add first the black cards. 26 out of 52 cards are black, half the deck. Then minus, subtract away the cards that I counted twice. I counted 10 cards out of 52 twice. The 2 2s, the 2 4s, the 2 6s, the 2 8s, and the 2 10s that are all black cards. So I added all of one group plus all of the other group minus anything I happen to count twice. That's how this addition rule works. So 20 plus 26 is 46. 46 minus 10 is 36 out of 52. And I end up with 9 over 13. So what's the probability of drawing an even number and a black card? I think you're beginning to see the pattern here. That is simply, those are simply these 10 cards out of 52 that are part of both groups. All right, the 10 black even numbers. So then that's 10 out of 52, or 5 over 26. How about a red face card? This should be a red face card, or a jack. Okay, so the face cards are the jacks, the queens, and the kings. All right, so again, or means add. Let's take each one separately. How many red face cards are there? Well, there's 2 red jacks, hearts and diamonds, 2 red queens, and 2 red kings. So there's 2, 2, and 2. So that's 6 total cards out of 52. Or means plus. Jacks are a suit, and there are, jacks are a card. I'm sorry, jacks are a card. It's early morning for me too right now. Jacks are a card. They're right here. So how many jacks are there? There's 4 of them total out of 52. Remember, at first you're just adding up total groups. Then you are subtracting away anything that you may have counted twice. Did we count any cards that are both jacks and red? Sure we did. We counted the red jacks in this first group, and we counted all the jacks in the second group, so we need to subtract away the 2 red jacks, which are the jack of hearts and the jack of diamonds. So I'm going to subtract away the 2 cards that are part of both groups. And 6 plus 4 is 10. 10 minus 2 is 8 cards out of 52, which reduces to 2 over 13. Red card, a red face card, and a jack. Well, once again, those are just these 2 cards, the red jacks. And so that's 2 out of 52, which is 1 out of 26. And that's it for that question right there. So now let's go back up to the top of the worksheet. Let's take this, what we've done in all of these left column problems, and let's formalize it. What have we been doing? We've been taking all of one group plus all of the other group and subtracting away anything that they have in common. So now, as a formula, if events are not mutually exclusive, to find the probability that A or B occur, I take the probability of A, the whole thing, plus the probability of B. But then I need to subtract away what they share in common. How do I write what they share in common? I simply write the probability that A and B occur together. And I'm going to box this formula right here because this is the one you're going to use to answer any addition rule problem right here. the probability of A or B occurring, or means add, is the probability of one thing plus the probability of the other thing minus the probability they occur together. All right, I'm going to do 2 more examples with you, and that's it. Example 3. Select a number between 1 and 100, inclusive. This word inclusive is important because it simply states that I'm including 1 and I'm including 100. What that means is that for all of these problems, my denominator is going to be 100. So what's the probability of being prime? Again, you need to consult your reference sheet. I have a list of prime numbers there from 2 through 1,000. Count up all the prime numbers that you see from 2 all the way up to 100. Pause the video if you need. Count them up. Okay, there are 25 prime numbers on that chart, and that reduces to 1/4. Part B, what's the probability that I just select a number between 1 and 100 inclusive that is less than 50? Notice, it says nothing about prime there. So there's just 49 numbers that are less than 50, 1 through 49, out of 100. So there's my answer there. Here's my answers here. What's the probability that the numbers are even from 1 through 100? Well, from 1 through 100, half the numbers are odd, half are even, so that's 50 out of 100, which is 1/2. Prime and even. I believe we learned the other day there's only one number that's both prime and even. It's the number 2. So that's just one number out of 100. Prime or even. So to use the formula from the first page, that's going to be the probability of being prime plus the probability of being even minus the probability of being both prime and even. Or I'll even write the words and even. But wait, didn't we answer all 3 of these questions already? Being prime is part A. Being even is part C. And being prime and even is part D. Hot dog. Let's do it. So prime, without writing the reduced answer, is 25 out of 100. Plus even from part C is 50 out of 100. Minus the probability of being both prime and even, which is just the 1 out of 100 from part D. I just took parts A, C, and D, added, put them all together into this problem, and I get 75 minus 1, which is 74 out of 100. And that equals, in a reduced form, 37 out of 50. How about that? Prime or less than 50. Once again, if I use the formulas that I've talked about, that's the probability of being prime plus the probability of being less than 50 minus the probability of being both prime and less than 50. Once again, we found those. Probability of being prime is part A, 25 out of 100. Less than 50 is part B, 49, so plus 49 out of 100. Minus the probability of being prime and less than 50. Oh, did we find that yet? No, we didn't. So pause the video and count up all your prime numbers that are also less than 50. Okay, unpause, and hopefully you found the 15 numbers that are prime and less than 50. So that's 15 over 100. All right, if I add and subtract, I get 59 over 100. Okay, I have 1 minute left before I have to stop this video. So let's just go through some of these problems in number 4, what we can cover in a minute. Select numbers at random between 1 and 12 inclusive. That means my denominator will be 12. What's the chances that the number is 4 or even? Well, only one number out of 12 is 4, plus the 6 numbers out of 12 that are even, minus anything we've counted twice. Did we count anything twice? Well, yeah. Isn't 4 also an even number? So yes, sometimes the addition rule is a bit redundant. I'm going to subtract away the one number that I counted twice, the number 4. So it seems weird that I'm adding the 1 out of 12 simply to subtract it again, but sometimes the addition rule works that way. And I end up with the 6 out of 12 that's in the center of that problem, which is 1/2. Everyone, I'm going to call it right there. I believe now you have enough information to do your addition rules homework and email me with any questions that you have.